Hello friends, welcome back to Edupedia Word Videos, your destination to free online education. This video will be dealing with some two proof type questions based on trigonometry. Let us have some most useful formulas in trigonometry. The first one is sin squared theta plus cos squared theta equals 1. The second one says secant squared theta minus tangent squared theta equals 1. The third one, cosecant squared theta minus cot squared theta equals 1. The fourth is sine over cos is tangent, whereas the reciprocal of this fraction, that is cos over sine theta, is cotangent. So let us have first question. It says prove that this left hand side equals this right hand side, that is both the left hand side and right hand side conveys the same meaning. Friends, in these two proof type questions, it is more convenient to pick up the complicated side and simplify it and make it equal to right hand side. If the picked up side has become equal to the other side by proper conversions, we have proved that question. So let us pick up here left hand side, which says cos A over 1 minus tangent A plus sin A over 1 minus cotangent A. Now we can't use the identities involving square, that is sin squared theta or any other term, because we don't have any square term in this left hand side, but we need only sine and cos of an angle A in right hand side. So we have cos and sine in numerical, but in the numerator, but in the denominator we need sine and cos. We can convert it by using these two formulas. So left hand side become cos A over 1 minus sine A over cos A plus sine A over 1 minus cos A over sine A. So in the denominator of the major fraction we can take LCM and we will get cos A over cos A as the LCM, and over here cos A and sine A over here. Similarly, for the second fraction, the second part, the LCM is sine A, and we have sine A minus cos A in the numerator of the major denominator. So friends, if we have a fraction, that is numerator over denominator, where denominator further consists of numerator and denominator, then what the simplification process does, this denominator is brought and multiplied with the numerator. Whereas if we have two fractions at both the numerator and denominator, then the lower part, that is denominator, is bring to the topmost part, and this n1 is multiplied with d1. So simply the lowermost part is brought at the topmost position and the second lowermost part at the downward position. Whereas if we have fraction in the numerator and the denominator is having just a single term, then we convert this denominator as the fraction by providing 1, and now again it become a condition like this. So bring this 1 to the upper part and d1 is multiplied by d. So simply the lowermost part is to be brought at the topmost part. See over here it was d1, the lowermost part, because we can't further resolve it into fraction, this part, whereas in this case it was n1 over d1 over d. So we can resolve this denominator into further fraction by putting 1, so 1 was brought to the topmost position, whereas in this case the lowermost part was at the topmost part, is brought at the numerator part, the topmost part, and the second lower part at the denominator of the upper fraction. So in this case we have the first condition, that is numerator is alone, whereas we have fraction and denominator. So this kind of equation can't be resolved further, so the lowermost part will become the numerator. Similarly, now friends, if we see the denominator of two terms, first is cos A minus sin A and the second is sin A minus cos A. So we can convert this sin minus cos into cos minus sin by simply having the minus sign as common. Now both the denominators can be made same. So we have here cos A minus sin A, and taking minus as common, we have cos A minus sin A over here. Now this minus will be multiplied by this plus and will result in the whole minus, whereas cos A into cos A is cos square A and sin square A over here. Now friends, since both have the same denominators, so the equation becomes, this side, left hand side, becomes the LCM as cos A minus sin A and numerator as cos square A minus sin square A. Now using the identity a square minus b square equals a minus b into a plus b, we have cos A minus sin A into cos A plus sin A over cos A minus sin A. So we have this factor common in numerator and denominator, and we can easily cancel that. So this part becomes 1, and 1 into this term is nothing but cos A plus sin A, or sin A plus cos A, interchanging the places of sin and cos. This is the required right hand side. Hence the given question has been proved, because we have modified or simplified left hand side into right hand side. Let us move on to the second question. In this case we have to prove this left hand side equal to this right hand side. So let us have left hand side, which is cot of x over 1 plus tangent x Friends, if we compare the left hand side and right hand side, we have cotangent x at both the numerators. This conveys that we have to less modify the numerator. But on the other hand, in the denominator, here it is tangent x and here it is secant square x of the trigonometric ratios. So somehow we have to convert this tangent x into secant square x. See, the only formula over here which can convert it is this one. But it needs tangent of theta and its degree 2. How can we have degree 2 of tangent over here? We have many options. Say we can multiply both the numerator and denominator by tangent of x. It will give us cotangent into tangent, and in denominator tangent x plus tangent square x. No doubt we have achieved tangent square x, but we have also gained tangent x, the unnecessary term, because here we have to get rid of this tangent x and we have brought an additional tangent x over here. But if we use the identity a plus b into a minus b, which is a square minus b square, we will have only two terms. First will be of 1 squared, that is 1, and the other will be tangent square x. So we'll be doing sum. Now cotangent x into tangent x, it is sine over cos from here and cos over sine. So cos get cancelled by cos and sine by sine. So it is 1. Now multiplying numerator and denominator by 1 minus tangent x, we have left hand side as cotangent x 1 minus tangent x as its multiple factor, and this. So the denominator becomes a square minus b square, that is 1 square, which is 1, and tangent square x. Cotangent x into 1 is cot x, and cotangent x into tangent x, we have proved that it is 1. So we have achieved numerator, but the only thing left is some modification in denominator. See, here secant square minus tangent square theta is 1. So secant, what is minus tangent square theta? It is 1 minus secant square theta. Friends, it must be cleared over here that here s and c are not actually shorthand terms for sine and cos. I have used it so just to save the calculation time. So now moving on to the question, minus tangent square theta is 1 minus secant square theta. So we have 1 plus the minus value, that is 1 minus secant square theta. Now 1 plus 1 is 2, and we have here secant square x. So we have achieved clearly the right hand side. Hence, starting from left hand side, we have again achieved right hand side, and hence the given question has been proved. Let us have another question. The question says, if sin theta plus cos theta is under root 2 cos theta, prove that cos theta minus sin theta is under root 2 sin theta. So we are given sin theta plus cos of theta equals under root 2 cos theta. Since it is the given equation, we will use now this equation to achieve this to prove part. Friends, if we look at the formulas, it involves sine square and cos square, or we can have sine and cos, but it is of no use in this case, the tangent theta. So here it is only sine and cos. We can't use sine square and cos square formula directly here, but what are the possible alternatives? We can separate the like terms, that is sine theta on one side and cos theta terms on the other side. So it becomes cos theta equals, now we can have cos theta common, which will give us under root 2 minus 1. In the to prove part, we need under root 2 with sin theta. Cos theta has its coefficient as 1. So, but here the coefficient is under root 2 minus 1. So, we can divide both the sides by under root 2 minus 1 to get rid of this unnecessary under root 2 minus 1 in right hand side, that is the RHS having cos theta. So divide both sides, that is left hand side and right hand side, by under root 2 minus 1. It will give us sin theta over under root 2 minus 1 equals cos theta over under root 2 minus 1 into under root 2 minus 1. Friends, we can divide both the sides because if 4x is 4x, then if we divide both the sides by 2, then it will become 2x is 2x. That is, the equality of the equation is still stored. So we can divide both the sides by the same factor. It is mathematically correct. So here the common factor is under root 2 minus 1, it gets cancelled. So we are left with sin theta over under root 2 minus 1 is cos theta. Now we need under root 2 the coefficient with sin theta, but here it is on the denominator side. So what can we possibly do? Either we can multiply and divide the left hand side by under root 2, which will give us the numbers as under root 2 over top and 2 minus under root 2, root 2 into root 2 is 2 in the denominator. So the root 2 in denominator still persists, whereas to get rid of this root 2, we can multiply and divide by under root 2 plus 1. That is simply rationalizing, which will bring us under root 2 plus 1 at the top and a square minus b square, that is 2 minus 1, that is 1. The denominator will become 1 over here. So we will adopt the second method. Multiply and divide numerator and denominator of left hand side by under root 2 plus 1. So we have under root 2 plus 1 over sine theta into sine theta over under root 2 plus 1 into under root 2 minus 1. So it will give us a square minus b square, that is under root 2 whole square minus 1 equals cos theta, which implies under root 2 sine theta plus sine theta over 2 minus 1, that is nothing but 1, equals cos theta. So here we need cos theta minus sine theta on right hand side. So rearranging the terms, we have under root 2 sine theta equals cos theta minus sine theta, because this one is, oh, you can say cross multiplied with this cos theta and will bear cos theta. So we have achieved cos theta minus sine theta as under root 2 of sine theta, which is the desired result. Hence the given question has been proved. So friends, this was all in this section. I'll be covering some more to prove type question in the upcoming video. Thanks friends for watching Edupedia Word videos.